Hi, today we will continue chapter 3 with the continuous improvement technique, which is total quality management, PDCA or PDSA, and Six Sigma. What is total quality management or TQM? TQM is a quality system which involves entire organization from supplier to customer to meet or exceed their needs through company-wide continuous improvement in all product or process along with proper problem-solving methodology. Okay, if you still remember the method that the technique that we learned before, so which involved the entire organization from bottom to the top management. So what is the techniques? Do you still remember Kaizen? Okay, Kaizen. Okay. The term TQM, T is referred to total and is the mean the responsibility for achieving quality with everyone no matter what's their function. Q is a quality. The primary task of any business is to understand the needs of the customer, then deliver the product or service at the agreed time, place and price on every occasion, and this will retain current customer. M is management. Top management lead the drive to achieve quality for customer by communicating the business vision and mission to the employee. Scope of TQM. TQM is the foundation for activities which includes commitment by senior management and all employees, meeting customer requirements, reducing development cycle time, just in time, improvement team, reducing product and service costs, system to facilitate improvement, employee involvement and empowerment, recognition and celebration, challenging quantified goal and benchmarking, focus on process or improvement plan. This shows that TQM must be practiced in all activities by all personnel, which including manufacturing, marketing, engineering, R&D, sales, purchasing, human resource, and others. The principle of TQM. There are five principles, which is continuous improvement, employee empowerment, benchmarking, just in time, and implementing TQM. Continuous improvement, if you still remember Kaizen, it represents continuous improvement of process and customer satisfaction. It involves all operation and work units. So we also call it Kaizen, Zero Defect, and Six Sigma. Employee empowerment. Getting employee involved in product and process improvement. 85% of our quality problems are due to process and materials. Okay, what is the technique that we want to get employee involved? Talk to workers, support workers, let workers make decisions, build team and quality circles. Quality circle is a group of 6 to 12 employees from same work area meet regularly to solve work-related program, so at least 4 hours per month, facilitated trains and help with meeting. Benchmarking. Select best practice to use as a standard for performance. Step is determine what's to benchmark. Form benchmarking team, identify benchmarking partner, collect benchmarking information and take action to meet or exceed benchmark. Just in time. What is meant by just in time? It's a pull system of production or purchasing, involve vendor partnership program to improve quality of purchase item, reduce all inventory level, inventory height, process and material problem, and improve process and product quality. So just in time mean if there's an order from customer, so we promise we will send the product after 2 days, so we need to meet the product need to meet the customer after 2 days. Okay, there's no delay. The fifth principle is implementing TQM. Successful implementation of TQM requires total integration of TQM into day-to-day operation. Cause of TQM implementation failures is because of lack of focus on strategic planning and core competency, obsolete and outdated organization cultures. Implementation of TQM. For TQM to be successful, the organization must concentrate on the following key elements. Okay, the key element is integrity, ethics, task, training, teamwork, communication, recognition, and leadership. So, it's such as a building. It can be divided into 4 groups according to their function. Okay, look at this building foundation. So, it's the integrity, ethic, and trust. This part is the foundation in the building. Building bricks is the leadership, teamwork, and training. Leadership, teamwork, and training, such as a building bridge. Recognition for the roof, such as a roof for the building, and binding mortar. Which binding mortar is the communication, so this binding mortar for the building. TQM tools, there are quality function deployment, Pareto chart, process chart, cause and effect diagram, and statistical process control or SPC. So this we will learn in the others chapter for this tool. Benefit of implementing TQM: increase in sales, reduce manufacturing expense, reduce net loss incurred by the company, reduce the defect product, accelerate reduce customer complaint, reduce and increase productivity rate from the pre-TQM to post-TQM period. Intangible benefit of implementing TQM: image of the organization has improved, reduction in inventories, short lead time in design, manufacturing, procurement, reduction in rejection and complaint, customer satisfaction, quality cost, percentage to turnover reduction, lower manufacturing cost, reduction in deviation, continuous improvement, and drastic reduction in defective and number of defects. What is PDCA or PDSA? Is a continuous improvement tools and also known as a shear hard cycle or dreaming wheel. So this is the guy who developed the PDCA and PDSA. P is referred to plan. D is do. C is check, or for the PDSA, S is study, and A is act for PDCA, and PDSA, A is adjustment. This is the guy who developed the tools. PDCA, developed by Walter Schulhart, is discuss the concept of the continuous improvement cycle, and Edward Deming was modified and popularized the Schulhart cycle to what now is referred to as the Deming cycle: plan, do, study, adjustment. Okay, this one try to understand this cycle. The overview of PDCA: plan, do, check. Okay, the goal is achieve the goal. If no, we need to modify the parameters and take action. And if it's Achieve the goals, yes, so straight way to take action. Plan. The definition of PDCA. Plan. Identify the problem. Analyze the problem. What, why. Do. Develop the solution. And also implement a solution. Check. Evaluate the result and achieve the desired goal. Action. Implement the full-scale solution and capitalize on new opportunity. Okay, this is the sample problem. Read and understand it, how we can implement PDCA. The explain it one by one actually in slide. Okay, now we continue with Six Sigma. And what is Six Sigma? It's a highly disciplined process that enables organization deliver nearly perfect product and service. The figure of C arrives statistically from current average maturity of most business enterprise. A philosophy and goal as perfect as practically possible, a methodology and a symbol of quality. Six Sigma is a statistical concept that focuses on reducing variation in process and preventing deficiency in product relative to customer requirement or specification. It set the goal of achieving capability level of 3.4 defect per million opportunity. So this is already set. It's a standard 3.4 defect per million opportunity. And sigma is the Greek symbol used for standard deviation of a population. This is the graph of Six Sigma process. To understand more about the process,
In this presentation, I will explain how Six Sigma strategy is implemented. Let's assume we manufacture using equipment that are calibrated to produce a product with a length of 100 millimeters. Of course, not all of the output is produced exactly at 100 millimeters, but the average length is 100 millimeters. The deviation of this equipment is high, and a lot of times users complain that the variation is too much and the products are not usable. We want to apply Six Sigma strategy in a way that lower specification limit is 97 millimeters, higher specification limit is 103 millimeters. We want the chance of a product being produced out of this range to be less than 0.00000002, which means that the chance of a product out of this specification to be less than 2 out of a billion. We will design the process with lower specification limit at 97 millimeters and higher specification limit at 103 millimeters, such that the chance of a product being produced out of this range will be 0.0000000197, which is less than 2 out of a billion. The chance of things farther than 6 standard deviations far from the mean happening is less than 2 out of a billion. So these red areas, which are farther than 6 standard deviations far from the mean, have a very minimal chance of happening, very close to 0. If we want the chance of an event out of the boundary of 97 millimeters and 103 millimeters to be less than 2 out of a billion, then 103 and 97 must be 6 standard deviations far from the mean. This means that 103 must be 6 standard deviations from the mean. That means that if we subtract 103 minus mu divided by sigma, that should be 6. The mean, we want the mean to be 100 millimeters. So 103 minus 100 divided by the standard deviation should be 6. That means the standard deviation should be 0.5 millimeters. The conclusion is that we have to buy new equipment with such reliability that the products do not vary more than a standard deviation of 0.5 millimeters. Now the question is that where should we set our control limits? To be sure that we will never get close to those boundaries, we have to set upper control limits and lower control limits such that our quality control will be alerted and corrective action happens way before our process gets close to specification boundaries. Experience shows that processes vary by as much as 1.5 standard deviations. Therefore, we will set our upper control limit at 1.5 standard deviations less than higher specification limit, and we will set lower control limit at 1.5 standard deviations above lower specification limit. Since we decided to set our higher specification limit at 6 sigma, then the upper control limit should be set at 4.5 standard deviations. Since we decided that the lower specification limit should be at negative 6 sigma, then the lower control limit should be at 4.5 standard deviations less than the mean. As you can see in this diagram, the chance of those things that are farther than 4.5 standard deviations far from the mean is about 7 out of a million. But the chance of those things that are farther than 6 standard deviations far from the mean is about 2 out of a billion. So when things that are 4.5 standard deviations far from the mean are happening, we have still a great chance that those things that are really out of a specification have little chance of happening. We can set the control limits around 4.5. We will consider a process out of control and we'll do corrective action when we find a number of products are produced beyond 4.5 standard deviations far from the mean, which means something out of range means products that are shorter than 97.75 millimeters or longer than 102.25 millimeters. When something like these or farther than these happen, then we will alarm the bell. We will be alerted that something is going wrong. This means that the chance of an event out of the specification boundaries, which is more than 6 standard deviations far from the mean, is 3,451 times less than the chance of an event out of control limits, where the alarms will ring. So around this point, we will be notified that this production is going out of control and there's still good safety margin. Even if the mean of the production in the long run shifts by 1.5 standard deviations to 100.75 millimeters, the chance of products being produced out of the specification limitations, the chance of products being produced longer than 103 millimeters will be less than 3.4 in million.
You need to watch this video. And this video explains how Six Sigma strategy was implemented. Okay, for relating Six Sigma to defect level, Six Sigma tip 3.4 part per million. So the error rates 99.9997%. So you can compare with the 5 sigma, 4 sigma, 3 sigma, 2 sigma, and 1 sigma. Six Sigma in perspective. If you play 100 rounds of golf per year and play at 2 Sigma, you miss 6 put per round. If you play at 3 Sigma, you miss 1 put per round. 4 Sigma, you miss 1 put every 9 rounds. 5 Sigma, you miss 1 put every 2.33 years. And 6 Sigma, you miss 1 put every 160. Again, I ask you, what is Six Sigma? Six Sigma is not a standard, it's not a certification, it's not another metric like percentage, but it is a quality philosophy and a way of improving performance by knowing where you are and where you could be. It's a methodology to measure and improve company performance practice and system. Why we need use Six Sigma is the overall business improvement, remedy defect or variability, reduce the cost, improve cycle time, and increase customer satisfaction. This is the company that use Six Sigma, such as Motorola, Sony, Citibank, Ericsson. There are 5 principles of Six Sigma, which is recognizing determinism, reducing variation, measuring for success, applying leverage, and managing risk. There are two Six Sigma methodology, which is DMAIC and DMADV. DMAIC is used for project aimed at improving an existing business process and is organization based. And DMADV is used for project aimed at creating new product and process design. Is based on customer need and satisfaction. So you can see the difference. This one is organization based and this one, the DMADV, is based on customer need and satisfaction. So is DMAIC define, measure, analyze, improve, and control. It's a logical and structured approach to problem solving and process improvement. An interactive process, continuous improvement, a quality tool which focus on change management style. Okay, the process define. What is define? Define the problem of opportunity, measure the current performance and capability, analyze to identify root cause, improve by implementing potential solution, and control by standardizing solution and monitoring performance. Define is a refer to who on the project and why, the scope of the project or improvement, key team member or resource for the project, critical milestone and stakeholder review and budget allocation. Measure, ensure measurement reliability. Okay, for this one I think you can read it. What is mean by define, measure, analyze, improve, and the description, explanation. So one by one you can read this slide. Okay, root cause analysis or fishbone. Okay, for this one you will learn in the next chapter. Okay, this one same thing. DMADV, define, measure, analyze, design, verify. What is mean by one by one? Okay, define, design the goals that are consistent with customer demand and enterprise strategy. Measure and identify characteristics that are critical to quality, product capability, production process capability, and risk. Analyze, develop, and design alternative. Create a high-level design and evaluate design capability to select the best design. Design detail, optimize the design and plan for design verification. Verify the design, set up pilot runs, implement the production process, and hand it over to the process owner. Okay, what is different between DMAIC and DMADV process? Okay, this one you try to understand what is the difference. Read it. The for the black belt training. So it start with the green belt, black belt, and master belt. For the green belt, time on consulting or training 2 to 5%, black belt 5 to 10%, and master belt is 80 to 100%. For the mentoring, find one new green belt. For the black belt, two green belt, and five black belt for master belt. When should Six Sigma be used? Its usage depends on the type of business. In general, there are processes that generate a lot of negative customer feedback, whether that customer is internal or external. The component of Six Sigma should be considered as a means to study and rectify the problem.